Hello, welcome to Jet Mathematics. I remain your host, Milton Ebiwari. In this video, we'll be looking at the nature of the rules of quadratic equation. Now remember our quadratic equation, the general form is ax squared plus bx plus c equals to 0. And using the formula method to solve, we derive that our value or the solution for this quadratic equation is minus b plus or minus square root of b squared minus 4ac all over 2a. So this gives us the solution for this quadratic equation. Now, this square root part, let's say, is equal to b squared minus 4ac is equal to d. This square root part is what determines the nature of the quadratic roots. So let's say here is equal to d, it is called the discriminant. D is called discriminant. Okay, it is what determines the nature of the roots of this quadratic equation. So if the value of d, this expression, is greater than 0, then the roots will be real and distinct. So if the value of d is greater than 0, if the expression here is positive, is greater than 0, then we'll have two roots that are real numbers and they are different in values. We'll have two roots, they are real numbers but different in values. So once d is greater than 0, we'll have real and distinct roots. Real and distinct roots. But if d is less than 0, we are going to have the roots will be complex or imaginary. So if we have the discriminant, which is d, the value inside the square root, to be less than 0, that is negative, we are going to have complex roots. The roots will become complex numbers or imaginary numbers. Okay, so if d is less than 0 or is negative, the value in the square root is negative, then our roots will be complex, or imaginary. Then finally we'll have, if we have d to be equals to 0, then the roots will be equal and real. So if the discriminant here is equals to 0, then we'll have real and equal roots. So the value of the roots will be the same twice, will be the same. So the two roots will have the same value. That means they are equal. And those values will be real numbers. Okay? So these are the three cases we can have. The roots can be real and distinct if the discriminant, the value in the square root, is greater than 0. The roots can be complex or imaginary if the value of d is less than 0, that is, it's negative. And then the roots can be equal and real if the values of in the square root is equal to 0. Alright, so in our next video we'll determine the nature of roots of some quadratic equation. Please like, share and comment on this video. Bye.